Hello everyone, welcome to my channel Chem Insider. In today's class, we'll be discussing about a topic of organic chemistry, which is quite important in every aspects of streams of fields which is related with chemistry. That is reagents. Yes, there are certain reagents which have their specific properties. Like for example, it may be a nucleophilic reagent or an electrophilic reagent or a reducing reagent, oxidizing reagent, etc. So now from today onwards we'll be discussing about certain different types of reagents and their specific functionalities and how are they going to react with our derived substrate and give us a desired product. Okay, so now in order to start, let us discuss what does a reagent mean. What do you mean by a reagent? A reagent is a molecule or a chemical compound which induces certain change in a substrate in order to form a product. That is, if you consider a reaction, it has reactant which is giving us a product, right? In a reaction, we have a reactant undergoing certain reaction to form product. Certain reactions, as we all have learned in the previous classes, that is, there are four different types of reactions like decomposition, combination, double decomposition, replacement reaction, etc. So some reactions there the reactant will just directly undergo reaction to form product, but in some cases the reactant are split into two. The reactants are split into two. The one is a substrate, one is called a substrate and the other is called the reagent. That is, a reaction, in some cases the reactant needs to have a deriving force or driving force which initiates the reaction to take place. That driving force is called as the reagent, and the compound on which the reagent acts or attacks upon is called the substrate. Like for example, if you consider a reaction of reduction of alkene, okay, if you consider for the reduction of alkene, it can be done with different reagents like hydrogen in presence of platinum or nickel, palladium, etc. Similarly, if you have to convert a given substrate into a product of alkene, like for example in this case we are converting alkene to alkane, if you have to do functionalities or reaction of this case, we need to have a reagent such as this hydrogen presence of platinum or hydrogen in presence of nickel or in presence of palladium, etc. So these reagents are the attacking species which brings about the change in the substrate to form a product. So how these reagents are to be classified? We need to classify reagents, right? Some of the reagent might be having some different reaction, some might be having other different reaction. Therefore, in order to understand these reagents specifically, we classify reagents into two types. One is electrophilic reagent. One is an electrophilic reagent and the other one is nucleophilic reagent. Usually, electrophilic reagents is also called as Lewis acids. Electrophilic reagents are called as Lewis acids, whereas nucleophilic reagents are considered as Lewis bases. Lewis acid and Lewis bases. So electrophilic reagent is also called as Lewis acid, whereas nucleophilic reagent is called as Lewis bases. Now let us just first discuss about electrophilic reagents. So electrophilic reagents are of two types. One which may be of positive charge species. Electrophilic reagents are of two types. One which are of positive charge species and the other are usually neutral species. So electrophilic reagents are also of two types, one which is of positive charge species and the other is of neutral species. So positive charge species and neutral species. We know positive charge species are attacked by the anion present in the substrate itself. But in case of neutral reactions or neutral um, electrophilic reagent, what happens is the neutral electrophilic reagents are attacked by the substrate because these neutral reagents may have vacant octet orbitals. These may have vacant octet orbitals. This might be a main reason for a electrophilic neutral reagent to attack the substrate, or it may be having vacant p or d orbital. It may have a vacant p or d orbital. If the reagent has vacant p or d orbital, or it may have a vacant octet orbital, which results in the substrate attacking the electrophilic reagent, or the electrophilic reagent may attack the substrate. And further, the third most reason for this neutral electrophilic reagent to attack may be because of presence of multiple bonds. If the electrophilic reagent, which is neutral in nature, carries multiple bonds, then it might attract the substrate. Whereas the positive charge reagent, we know the concerns, how it does react with electrophilic reagents or the substrates. But in case of neutral reagents, these 3 points are the main reason for electrophilic reagent to attack the substrate. Okay, so now let us check out about the nucleophilic reagents. So how does this nucleophilic reagent work and how does it attack? A nucleophilic reagent again are classified into 2 types, just similar to electrophilic reagents. As quite similar to electrophilic reagents, nucleophilic reagents are also classified into 2 types, one which are negatively charged and the other again which are neutral in charges or neutral in nature. So the negative reagents, like for example, you can consider for those of examples OH minus, electronegative elements, OH minus, Cl minus, or any halogens, or any electrophilic electronegative elements, those can also be considered as a negative nucleophilic reagent. But what is the reason for neutral nucleophilic reagents to attack the substrate? So the main reason, the first very important reason might be the presence of lone pair of electron. If a neutral nucleophilic reagent carries lone pair of electrons, then it is quite possible that it might be attacking the substrate because of the presence of lone pair of electron. Like for example, if you consider H2O molecule, here oxygen carries 2 lone pair of electrons. Out of these 2 lone pair of electrons, 1 lone pair of electron might attack the substrate to form a nucleophilic substitution reaction, which might later involve in the removal of hydrogen atom or 2 hydrogen atoms, etc. Next, the second reason for a neutral nucleophilic reagent to attack a substrate is maybe because of the presence of organometallic bond. Yes, organometallic bond may also be a reason for a neutral nucleophilic reagent to attack our substrate. So, if you consider for the reagents, we have 2 types, a nucleophilic reagent and the electrophilic reagent. Electrophilic reagent called as Lewis acid, nucleophilic reagents is called as Lewis bases. Electrophilic reagents are classified into 2 types, positive charged and neutral species. Again, nucleophilic reagents are also classified into 2 types, negative charged and neutral species. Okay, so this is about the reagents and different types of reagents. Now, how does this reagent act or attack a given substrate? So whenever you consider for a reaction, the attack of nucleophile or electrophile on a substrate, in common if you can say, a reagent attacks a substrate in such a way that the reaction has to be fruitful. We all know the collision theory, right? So collision theory says that whenever a reaction has to be formed, the reactant species have to be collided in order to form a fruitful reaction which can be later converted to product. So therefore, there are certain points which we have to remember in order to consider a reaction to be converted to a fruitful product. That is, we have to overcome certain criteria which is already present in the reactant or the substrate, which might oppose the completion of the reaction. Like for example, if you consider a species of norborane, which is like this, so here if you number these positions, we have 7 carbon atoms here, 1 2 3 4 5 6 and 7. Okay, so here if a reagent is attacking, let us say R, okay, if a reagent is attacking these given carbon atoms present in this particular structure, it might be attacking from this direction or it may be attacking from this direction. If the reagent is attacking from this direction, it is called the equatorial attack. If the reagent is attacking from this direction, it is called the axial attack. That is, if it is perpendicular in this direction or in this direction, this is called axial attacks. If it is in this direction or from this direction, then it is called the equatorial attacks. Okay, so one is axial attack, one is equatorial attack. It is denoted by the symbol A for axial attack. Equatorial attack is denoted by the symbol E. Okay, so this axial and equatorial attack is one type of representation of attack possible by a reagent on the substrate. We can also call them as endo or exo attack. So the endo or exo attack is quite similar with respect to equatorial or axial attack, but in cases of certain different examples only. Okay, so what is an endo attack and what is an exo attack? Endo attack is usually called as axial attack. Endo attack is usually known as axial attack, that is, it has to attack the carbon atom present in the species in the axial direction, whereas the exo attack is from the outer side. Exo, it should be present on the outer side of the plane of the compound. That is nothing but the equatorial attack. So exo attacks are usually equatorial attacks, whereas endo attacks are axial attacks. Okay, so these are the two different types of attacks which is usually observed in case of reagent attacking a substrate, endo or exo, or you can also call it as axial or equatorial attacks. Okay, in the next class we'll discuss more about these endo, exo and axial equatorial attacks with brief descriptions also and some certain examples also. I hope you have understood this introduction class of reagents. If you have any doubt, please do comment down below. If you need more videos regarding the reagents, please subscribe to my channel and share this video among your friends who may be of need of these reactions, these particular topics, in order to learn chemistry to a better terms. Thank you for watching.